Somewhere, in the direction of the constellation Ophiuchus, a small battered machine is escaping everything humanity has ever known. It is currently over 15 billion miles away from the hands that built it, drifting through an environment so hostile and so unimaginably empty that the human mind can barely comprehend the scale of its isolation. For nearly half a century, this machine, Voyager 1, has been a loyal employee of NASA. It has sent back the first close-up views of Jupiter's Great Red Spot and the intricate braided rings of Saturn. It has looked back from 6 billion kilometers away to capture our entire world as a single fragile pixel of light, the pale blue dot. But today, the era of Voyager as a scientific instrument is coming to an end. We are entering what mission controllers call the dying decade. Most people believe the story of Voyager ends when the power dies, but that is a catastrophic misunderstanding of the physics of the void. In reality, the moment Voyager's radio falls silent isn't an ending, it is a birth. It is the moment a piece of 1970s technology transforms into a cosmic fossil, an independent celestial object that will outlast the very planet that created it. To understand why this is happening, we have to look at the heart of the machine. Voyager doesn't use solar panels. Out where it is, the sun is nothing more than a particularly bright star, incapable of providing warmth or energy. Instead, Voyager beats with a nuclear heart, 3 radioisotope thermoelectric generators, or RTGs. These containers are filled with spheres of plutonium-238. As the plutonium decays, it generates heat, which is converted into the electricity that runs its vintage computers and its 22-watt transmitter. But physics is unforgiving. Plutonium has a half-life of 87.7 years, and every single day, that nuclear heart grows a little colder. NASA engineers are currently performing a desperate slow-motion triage. They are losing about 4 watts of power every year, roughly the energy needed to power a single LED bulb. To keep the mission alive, they have been forced to make heartbreaking choices. They have turned off the heaters that keep the instruments from freezing. They have permanently disabled the cameras, making Voyager blind so that it can keep talking. They have even shut down the heaters for the thrusters, risking the plumbing of the ship just to squeeze out a few more months of data. Current projections tell us that by 2025, there won't be enough power left to run a single scientific instrument. By somewhere between 2030 and 2036, the electricity will drop below the absolute threshold required to point its high-gain antenna toward Earth. Imagine that final day in 2036. In a darkened room at the Jet Propulsion Laboratory, a group of engineers will be staring at a screen, waiting for a signal that takes over 22 hours to travel across the vacuum at the speed of light. They will hear a faint, flickering pulse, a final bit of data from a computer with less memory than a modern car key. And then there will be a flatline. Total permanent silence. In the public eye, this is where the mission concludes. The press will write the obituaries. The history books will close the chapter on the greatest era of 20th century exploration. But in the cold reality of interstellar space, Voyager 1 is just getting started. While the radio will be dead, the probe itself will not be dead in the way we think. This brings us to a phenomenon that almost every other documentary ignores, the thermal ghost. Even after the last circuit flickers out, those spheres of plutonium will continue to decay. For hundreds, perhaps thousands of years, Voyager 1 will continue to glow in the infrared spectrum. It will be a tiny, warm ember drifting through a world that is nearly absolute zero. To an advanced civilization with sensors we can't yet imagine, Voyager wouldn't look like a piece of space junk. It would look like a ghost ship, a metallic anomaly emitting a rhythmic heat signature that shouldn't exist in the deep void. It will be a thermal ghost, a lingering whisper of human life that continues to radiate long after its creators have forgotten its position. But there is a deeper mystery here that the original mission planners never fully addressed. When we lose contact in 2036, we lose our ability to track Voyager. We will no longer be able to tell it how to fire its thrusters to avoid the microscopic grit of the interstellar medium. We will no longer be able to correct its course. Up until now, Voyager has been on a leash, tied to Earth by a thread of radio waves. In 2036, that leash snaps. For the first time, Voyager 1 will be truly free. It will no longer be a NASA spacecraft. It will be a new kind of entity, a human-made comet with no tail, a metallic seed cast into the galactic wind. As it drifts past the 20 billion kilometer mark, it enters a realm of interstellar weathering. We often think of space as a perfect vacuum, but it's actually filled with a thin fog of ancient stardust and high-energy cosmic rays. Without its magnetic shield, and without the protection of the sun's heliosphere, Voyager's skin will begin to undergo a slow, agonizing transformation. The aluminum cover of the golden record, the gold-plated copper discs carrying the sounds of our world, they are about to begin a 10 billion year test of endurance. We are used to measuring time in years, decades, or centuries, but to follow Voyager where it's going, we have to abandon those human scales. We have to start thinking in geological time. We have to imagine what happens to a machine when it is left alone in a freezer for 1 billion years. This isn't just a story about a lost probe, it is a detective story where the crime scene is the entire Milky Way galaxy. In the chapters to come, we are going to follow this ghost ship through the 3-century wall of the Oort Cloud. We are going to witness it surviving the collision of 2 galaxies. We are going to watch as the sun itself dies and Earth is reduced to ashes, leaving Voyager as the only physical evidence that you or I, or anything we ever loved, actually existed. The year is 2036. The final signal has just flatlined on a monitor in California. On Earth, people are moving on. But 15 billion miles away, a 1,600-pound monument of gold and aluminum is just picking up speed. It is heading toward a future where humanity is a forgotten word, and where the only thing left of our civilization is a silent, drifting fossil, carrying a message to a universe that hasn't even been born yet. Where will Voyager 1 end up 10 billion years from now? To find the answer, we have to go further than any telescope has ever looked. We have to go to the very end of time itself. The silence that begins in 2036 is not a void. It is a heavy physical presence. For decades, the constant back and forth of radio waves provided a tether, a way for us to feel the heartbeat of our most distant explorer. But now, that thread is severed. Voyager 1 is no longer a conversation, it is a monologue. It is drifting into a region of space that serves as the ultimate border wall of our home, the Oort Cloud. To truly understand where Voyager is going, we first have to admit a common lie. Voyager 1 has not left the solar system. It has only left the neighborhood. Most of us remember the headlines from 2012. NASA announced that Voyager 1 had crossed the heliopause and entered interstellar space. In our minds, we pictured the probe breaking through a finish line and sailing into the great beyond. But the heliopause is merely a magnetic boundary. It's the place where the sun's breath, the solar wind, finally loses its strength and is pushed back by the cold pressure of the galaxy. It is a change in the weather, not a change in the map. The true physical boundary of our solar system is the Oort Cloud, a gargantuan spherical shell of icy debris and frozen comets that marks the outermost limit of the Sun's gravitational empire. Voyager is currently traveling at roughly 38,000 miles per hour, or 17 kilometers per second. Even at this blistering speed, fast enough to cross the Atlantic Ocean in a few minutes, the scale of the Oort Cloud is so vast that it mocks our measurements. Voyager will not even reach the inner edge of this cloud for another 300 years. Think about that time frame. By the time Voyager enters the true solar system border, every human being alive today will be long gone. Our current technology will look like stone tools, yet Voyager will still be the same 1970s machine, its circuits frozen, its mission long forgotten by a world that has moved on to other stars or perhaps vanished into history. This 300-year wait is merely the lobby of the Great Transit. Once Voyager enters the Oort Cloud, it begins a 30,000-year journey through a frozen cemetery. This is the 3-century wall, a region extending roughly 6 trillion miles into the darkness. To put that in perspective, light from the sun takes about 8 minutes to reach Earth. It takes 23 hours to reach Voyager right now, but to reach the far edge of the Oort Cloud, light must travel for nearly 2 years. This is the true scale of the sun's reach. This is the magnitude of the prison Voyager is trying to escape. As Voyager drifts through this 30,000-year transit, something subtle and terrifying begins to happen to its physical form. We often imagine space as a perfect, empty vacuum, but it is actually filled with a thin, abrasive fog of interstellar dust. At 17 kilometers per second, even a microscopic grain of dust becomes a kinetic weapon. This is the era of interstellar weathering. Every few miles, a tiny particle, no larger than 1,000th of a millimeter, slams into Voyager's aluminum skin. These impacts are so fast that they don't just dent the metal, they vaporize it. Each grain creates a microscopic crater, a tiny explosion of energy that slowly, atom by atom, sandblasts the spacecraft. Imagine the golden record, that gold-plated copper disc carrying the sounds of Earth. It sits inside an aluminum protective jacket. During these 30,000 years in the Oort Cloud, that jacket is the front line. It is being pitted and scarred by the remnants of dead stars. The sounds of Earth are being shielded by a metal shell that is slowly being eaten away by the galaxy itself. If you could see Voyager 400 years from now, it would no longer look like the shiny white and gold icon from the NASA press photos. It will be duller, its surfaces roughened, looking more like a piece of sea-tossed driftwood than a pinnacle of engineering. But while the exterior is being weathered, the thermal ghost within is still flickering. Even 3 centuries into its journey, the plutonium spheres in its heart are still decaying, still emitting a faint infrared glow. In the absolute zero of the Oort Cloud, where the temperature hovers just above minus 459 degrees Fahrenheit, Voyager is a warm anomaly. It is a tiny heat signature moving through a field of ice. This is the era where the needle in an ocean problem becomes most acute. The Oort Cloud contains billions of objects, most of them much larger than Voyager, but those objects are cold. They are dead. Voyager is the only thing in that 6 trillion mile shell that carries the residual heat of a nuclear reaction. It is a man-made ember in a God-made freezer. As Voyager 1 navigates this icy gauntlet, it enters a state of gravitational chaos. Currently, it is still a subject of the Sun, but as it moves further into the Oort Cloud, the Sun's grip weakens. At about 30,000 years out, at the very edge of the cloud, Voyager reaches a tipping point. It begins to feel the gravitational whisper of other stars more strongly than the pull of the Sun. This is a dangerous, unpredictable phase. The Oort Cloud is not a static place. It is a chaotic dance of ice. If Voyager passes too close to a large cometary body, something the size of a small moon, the resulting gravitational tug could alter its trajectory by a fraction of a degree. Over 30,000 years, a fraction of a degree is the difference between Voyager eventually flying through a nearby star system or being flung into the empty great voids between the galactic arms. We like to think of its path as a straight line, but in reality, Voyager is surfing the gravitational waves of billions of objects we haven't even mapped yet. It is a blind traveler in a room full of invisible furniture. One wrong nudge, and its 10 billion year destination changes forever. To grasp the sheer length of this chapter of its life, we have to look back at our own history. 30,000 years ago, humans were painting caves in Lascaux and surviving the last ice age. That entire span of human development, from the first cave paintings to the invention of the internet, the moon landing, and the creation of Voyager itself, is the same amount of time Voyager will spend just trying to leave its home. For the next 300 centuries, while empires rise and fall on Earth, while the very languages we speak today become extinct and forgotten, Voyager will be doing one thing: crossing the Oort Cloud. It will be the only witness to the slow, agonizing passage of time in the outer dark. In this era, Voyager ceases to be a machine of the 20th century and becomes a relic of the human epoch. It is now an orphaned relic. If a passing extraterrestrial intelligence were to encounter it in the middle of the Oort Cloud in the year 25,000 AD, they wouldn't find a working probe. They would find a fossil from a long extinct epoch. They would see a craft that looks more like a natural celestial body than a high-tech emissary. The white paint will have been scoured off. The delicate instruments will be shattered by millions of micro-impacts, but the golden record, shielded behind its thinning aluminum wall, will remain. It will be the cosmic Rosetta Stone, waiting for a decoder that might never come. The tragedy of the Oort Cloud transit is its loneliness. Even within the cloud, objects are millions of miles apart. Voyager is traveling through a region of space that is technically populated by billions of comets, yet it will likely never see one. It is a journey through a crowded room where everyone is standing miles apart in total darkness. The interstellar weathering is the only thing that reminds Voyager it is moving. The tiny craters being carved into its chassis are the only record of its progress. As we approach the end of these 30,000 years, Voyager reaches the final boundary. It is 1.6 light years away from the Sun. Here, the gravity of the stars beyond, Gliese 445, Ross 248, and the distant giants of the Milky Way, begins to take the wheel. The Sun is now just another bright star in the rearview mirror, indistinguishable from the thousands of others. When Voyager finally crosses the outer edge of the Oort Cloud, it will have officially left the solar system. It will have escaped the cradle. But it isn't entering a new world. It is entering the deep stellar drift. It is stepping out of the local fog and into the galactic ocean. The 30,000-year transit is over, but the 10 billion year odyssey is just beginning. Voyager has survived the border. It has outlived its creator's history. Now, it must survive the stars themselves. The year is approximately 32,036 AD. On a planet once called Earth, the very memory of a place called NASA has likely dissolved into myth. But at the edge of a great shell of ice, a battered, graying machine of aluminum and gold finally feels the pull of the open galaxy. It has broken free of the 3-century wall. It is now a true citizen of the Milky Way, heading toward its first stellar encounter, carrying a message from a world that may no longer have a voice to speak it. Where it goes next will challenge everything we know about the stability of the universe. Because once Voyager is free of the sun, it isn't just traveling through space, it's traveling through the death of time itself. The year 2036 marks a boundary in the human story that we are currently unprepared to face. On that day, somewhere in a clean room at the Jet Propulsion Laboratory, the final packet of data will flicker across a monitor and then vanish into a flat line. The radio, which has hummed with the heartbeat of Voyager 1 for nearly 60 years, will fall silent, and the spacecraft will transition from a living extension of our curiosity into a frozen ghost ship. To most of the world, this is the end of the mission, but in the cold, unforgiving reality of the interstellar medium, a much stranger phenomenon is just beginning. While Voyager will no longer have the power to speak to us, it will continue to radiate a presence, a phenomenon known as the thermal ghost. To understand the thermal ghost, we have to look deep into the anatomy of Voyager 1, specifically at the 3 radioisotope thermoelectric generators, or RTGs, that have served as its nuclear heart since 1977. These are not traditional batteries. They are containers filled with spheres of plutonium-238. As this plutonium decays, it generates an immense amount of heat, which a set of thermocouples converts into the electricity needed to run its 1970s era computers. But this conversion process is inefficient, and a significant portion of that nuclear energy has always been shed as pure, raw heat. Physics is an unforgiving master, and plutonium-238 has a half-life of 87.7 years. This means that every single day for the last 5 decades, the nuclear heart of Voyager has been growing slightly colder, losing about 4 watts of power every year. By the mid-2030s, the electricity produced will drop below the critical threshold required to maintain its high-gain antennas alignment with Earth. The radio will go dead, and the heaters that keep the electronics from freezing will finally shut off. At that moment, the internal temperature of Voyager circuits will plummet toward the absolute zero of the surrounding void, which hovers at a staggering -459 degrees Fahrenheit. However, the radioactive decay of the plutonium does not stop just because the radio has failed. While there won't be enough heat to generate electricity, the spheres of plutonium will continue to glow with a residual atomic warmth for centuries, perhaps even millennia. After Voyager has become a silent relic, it will remain a warm anomaly in a universe of total cold. This is the essence of the thermal ghost, a heat signature that remains detectable long after the machine itself has died by human standards. Imagine a hypothetical alien astronomer, or perhaps a future human civilization with technology that dwarfs our own, scanning the direction of the constellation Ophiuchus. In a region of space where every other object is a frozen chunk of ice or a grain of dust at nearly absolute zero, they would see a pinpoint of infrared radiation. It wouldn't look like a star, and it wouldn't look like a comet. It would be a thermal ghost, a tiny rhythmic heat signature that betrays the presence of something artificial. The metallic composition of Voyager, its aluminum housing and gold-plated record, would stand out against the natural background of the cosmos like a lighthouse in a fog. This creates a haunting search and rescue, or interstellar archaeology hook, that most mission summaries ignore. For several hundred years following its 2036 silence, Voyager 1 will be more visible to the universe than it was during its active life. During its years of operation, its radio signal was a mere whisper, less than 1/1,000,000,000 of a watt by the time it reached Earth's massive 230-foot antennas. But as a thermal ghost, Voyager radiates its heat in all directions, a constant infrared beacon that tells anyone listening, something made by hand was once here. However, the scale of the challenge in finding this ghost cannot be overstated. This is what theorists call the needle in an ocean problem. Even with a heat signature, Voyager is effectively a single water molecule lost in the Pacific Ocean. The Milky Way is a vast 100,000 light-year wide expanse of stars, gas, and dust. Voyager is traveling at roughly 17 kilometers per second, a speed that feels fast to us, but in galactic terms, it is a crawl. It would take Voyager tens of thousands of years to cross even the smallest fraction of the distance to the nearest star. The statistical likelihood of an alien civilization stumbling upon this thermal ghost is near zero. Space is mostly empty, a cosmic desert where stars are separated by light years of nothingness. But near zero is not the same as impossible. If a civilization has mastered the ability to map the thermal signatures of their entire stellar neighborhood, they might notice this strange metallic ember drifting through the dark. They wouldn't find a working spacecraft. They would find an orphaned relic, a message without a sender, and a machine that outlived the very planet that dreamed it into existence. The thermal ghost represents a shift in the Voyager narrative from one of exploration to one of endurance. For the next millennium, Voyager will be a man-made ember, a physical testament to 1970s engineering that refuses to surrender its heat to the void. It is a period of transition where the probe is no longer a tool of NASA, but a celestial object in its own right. It is no longer an active spacecraft, but has transitioned into a frozen relic that carries the essence of humanity into a future where humanity might no longer exist. As the centuries pass, the thermal ghost will eventually fade. The plutonium-238 will continue to decay, its spheres growing colder and colder with each passing century. Eventually, the heat signature will drop below the level of detection for even the most advanced sensors, and Voyager will become truly dark, a tiny dark artifact that is finally totally one with the cold of interstellar space. But for that brief window of a few thousand years, Voyager 1 will be the most detectable thing humanity has ever placed in the stars. This era of the thermal ghost is the bridge between our current understanding of the mission and the deep time mysteries that lie ahead. It is the moment we realize that Voyager's legacy isn't just about the photos it took or the data it sent back. It is about the fact that we were brave enough to leave a mark on the universe that is etched in atomic heat. Long after the 2036 signal ends, that heat will remain as the last flickering candle of our species, burning in the middle of a dark, uncharted forest where no human eye will ever see it. By the time the thermal ghost finally vanishes, Voyager will be deep within the Oort Cloud, facing a journey of 30,000 years through a cemetery of ice. The heat may be gone, but the story is only just beginning. The probe has survived its death, and now it must survive the erosion of the galaxy itself. The 2036 silence was not the end. It was simply the moment the mission became eternal. 40 millennia have passed since the final whisper of Voyager 1 reached the massive antennas in the deserts of Earth. To put that in perspective, 40,000 years is roughly the same amount of time that separates us from the first modern humans who carved bone flutes and painted the walls of caves in the darkness of the Ice Age. Everything we call civilization, the rise of agriculture, the building of the pyramids, the Industrial Revolution, and the very launch of Voyager itself, is just a tiny 10,000-year flicker on the edge of this vast timeline. By the year 42,025 AD, Voyager 1 has reached its first major milestone in the Great Dark. It is making its first close approach to another star. For centuries, astronomers in the late 20th century calculated this moment with their early computers and slide rules. They identified a target, a small dim red dwarf star in the constellation Camelopardalis, known as Gliese 445. To a human observer on Earth in 1977, Gliese 445 was an invisible speck, a faint ember of a star far too dim to be seen with the naked eye. But for Voyager, it is now the most important object in the universe. As the probe drifts through the silence, it passes within approximately 1.6 light-years of this alien sun. That is roughly 9.4 trillion miles. In our human-centric view of the world, 9 trillion miles sounds like an impassable ocean. It is 100,000 times the distance between the Earth and the Sun. But in the grand architecture of the Milky Way, this is a backyard encounter. It is a near miss. Voyager is gliding past Gliese 445, like a ghost passing through a neighbor's garden in the middle of a dark night. But here's the mystery that the early mission transcripts often skip. If there is anyone living on a planet orbiting Gliese 445, what would they actually see? Imagine a civilization millions of years more advanced than our own, a species that has survived the volatile youth of their red dwarf star. Their sensors are not looking for radio waves. Those were a primitive technology they abandoned eons ago. Instead, they are scanning for anomalies in the deep field infrared. They are looking for things that do not belong in the natural order of the void. To them, Voyager 1 would not look like a triumph of engineering. It would look like a tiny, dark, metallic flake. By now, the thermal ghost, the residual heat from the plutonium heart, has likely faded into a memory. The probe is now a cold, inert object, its temperature perfectly matched to the absolute zero of the interstellar medium. Yet, it is still loud in a different way. The interstellar weathering we discussed in the previous chapters has now been at work for 40,000 years. The aluminum casing that protects the golden record is no longer smooth and polished. It is pitted and etched with the microscopic scars of 1 billion dust grain impacts. These tiny craters act like thousands of miniature prisms. If a beam of light from Gliese 445 were to strike the probe's battered surface, Voyager wouldn't just reflect the light. It would scatter it in a strange, non-natural pattern. To an alien observer, this wouldn't be a star or a comet. It would be a metallic anomaly. This is the finder narrative, the haunting possibility that Voyager's first encounter with another star is also its first potential discovery. What would an alien archaeologist think of this 1,600-pound relic? They would find a machine that is millions of times weaker than the technology they likely use to brew their morning coffee. They would see a computer with 68 kilobytes of memory, a brain so primitive it would seem like a fossilized insect trapped in amber. They would see magnetic tape, a storage medium that requires physical movement to read, and they would find the golden record. But here is the uncomfortable truth of the 40,000-year flyby. Even at its closest approach of 1.6 light-years, Voyager is still profoundly alone. The gravity of Gliese 445 is too weak at this distance to capture the probe. There is no slingshot here, no violent redirection like the one Voyager experienced at Saturn or Titan. Instead, Voyager simply glides past. It is completely unaffected by the red dwarf's pull. It doesn't slow down and it doesn't speed up. It just maintains its ballistic trajectory, a bullet fired in 1977 that is still moving in a perfectly straight line because there is nothing in the vacuum of space to stop it. This highlights the cosmic insignificance paradox. At this moment, Voyager is closer to another star than it has been to the Sun in 40 millennia. It is the closest it will be to home for a very long time. And yet the distance is still so vast that if you were standing on a planet orbiting Gliese 445, you could look directly at the patch of sky where Voyager was passing and see absolutely nothing. Even with our most powerful telescopes today, we would struggle to find a school bus-sized object 9 trillion miles away. Voyager 1 is a message in a bottle that has been thrown into an ocean so large that the bottle will likely never wash up on any shore. The flyby of Gliese 445 isn't a destination. It's just a signpost. It is a reminder that even when Voyager arrives somewhere, it is still effectively nowhere. As Voyager passes the midpoint of its encounter with the red dwarf, it begins to pull away. The star Gliese 445, which for a few thousand years was the brightest thing in Voyager's sky, begins to shrink back into a faint red dot. The deep stellar drift begins again. By the time Voyager 1 leaves the vicinity of Gliese 445, it is no longer just a human object. It has survived long enough to become a permanent feature of the Milky Way's geography. We have to consider what has happened back on Earth during these 40,000 years. On our home planet, the climate has shifted. Entire mountain ranges have begun the slow process of erosion. The very constellations that the NASA engineers used to navigate in 1977 have started to warp and distort as the stars move in their own independent orbits around the galactic center. But Voyager remains unchanged. It is a time capsule from a specific moment in 1977, a moment when a species of bipedal primates on a small blue planet decided they wanted to say hello to the universe. As it leaves its first stellar neighbor behind, the probe carries with it the recorded brainwaves of a young woman falling in love, the songs of humpback whales, and the greetings of 55 human languages, all of which might now be spoken by no one. This 40,000-year encounter is the last time for a very long time that Voyager will be near anything. It is now heading into the great empty, the vast sparse regions of the galactic neighborhood where stars are separated by even greater distances. It has passed its first test. It has survived the Oort Cloud. It has survived the thermal ghost phase, and it has survived its first encounter with another sun. Now the timeline begins to stretch. We are moving out of the era of tens of thousands of years and into the era of hundreds of thousands. We are heading toward an encounter with Sirius, the brightest star in our night sky, nearly 300,000 years into the future. But as Voyager drifts away from Gliese 445, the most haunting realization is this: Voyager is now older than the civilization that built it. It has entered a state of eternal drift, where it is no longer a guest in the galaxy, but a resident. The year is approximately 42,000 AD. A battered graying machine, etched with the scars of 40 millennia, is moving at 17 kilometers per second into the dark. It has just passed a star called Gliese 445. It didn't stop. It didn't wave. It just kept moving, indifferent to the fact that it had just completed the most significant journey in the history of its kind. Where will it go next? To find out, we have to look toward a future so distant that the Earth itself begins to disappear. We are moving into the deep stellar drift where Voyager 1 will outlive the very stars it passes. Beyond the faint red glow of Gliese 445, Voyager 1 returns to the deep stellar drift. We are now roughly 40,000 years into the future, and the spacecraft has successfully navigated the inner boundaries of its home. But as it pulls away from its first stellar encounter, a new and more subtle transformation begins. To understand this phase, we have to look past the mission logs and the orbital mechanics and focus on the physical body of the probe itself. We have to look at what time and the galaxy are doing to the metal. There is a common myth that space is a perfect, pristine vacuum, a place where things remain unchanged forever because there is no air to cause rust and no wind to cause erosion. But this is a dangerous misunderstanding of the interstellar medium. Space is far from an empty void. It is a shooting gallery of ancient stardust, high-energy cosmic rays, and microscopic debris left over from the births and deaths of stars. As Voyager 1 hurtles through the local interstellar cloud at 38,000 miles per hour, it is not moving through nothingness. It is moving through a steady, invisible rain of dust. At 17 kilometers per second, the physics of a collision change. Out here, there is no such thing as a soft impact. When Voyager encounters a grain of interstellar dust, something only 1,000th of a millimeter across, smaller than a speck of smoke, it doesn't just bounce off the hull. Because of Voyager's immense velocity, that tiny grain carries the kinetic energy of a miniature bomb. Upon impact, the dust grain and a small portion of Voyager's metal skin are instantly vaporized. The result is a microscopic crater, a tiny pit in the aluminum that marks another second of the probe's journey through the dark. This is the era of interstellar weathering. If you could stand on the boom of the spacecraft, you wouldn't hear anything. There is no air to carry the sound of the impacts, but you would see a constant silent flickering of microscopic sparks as the galaxy slowly chips away at the machine. Over hundreds of thousands of years, this process acts like a slow-motion sandblaster. It is a relentless atomic-scale erosion that is systematically erasing the human from the machine. Think about the aesthetic details of the probe as it left Earth in 1977. It was a masterpiece of 20th century engineering, with white painted surfaces, shiny gold-colored foil, and the bold red letters of the NASA logo. By the time Voyager has spent 250,000 years in the drift, those details are gone. The white paint, which was already beginning to flake and peel under the sun's ultraviolet radiation, has been scoured away by the dust. The structural lattice of the spacecraft, once hidden behind protective blankets, is now exposed to the raw environment of the void. The very shape of the machine is changing. The edges of the high-gain antenna, that iconic 12-foot wide dish, are becoming rounded and dull. The long, delicate booms that hold the magnetometer and the radioisotope generators are being pitted and scarred. Voyager is losing its sharp, intentional lines and taking on the weathered, organic appearance of a piece of sea-tossed driftwood. It is transitioning from a high-tech emissary into a fossil from a long extinct epoch. But there is one part of the spacecraft that is being protected with almost religious significance: the golden record. Encased in its gold-plated copper and shielded by an aluminum jacket, the record is the inner sanctum of the probe. While the outer skin of Voyager is being eaten away atom by atom, the aluminum cover of the record is absorbing the brunt of the damage. This cover was designed to survive for at least 1 billion years, but it is not a passive survivor. It is a sacrificial layer. As the sounds of Earth drift through the deep stellar drift, the aluminum jacket is slowly thinning. Every micro impact that carves a crater into that cover is a bullet that didn't hit the record itself. It is a haunting image. The record of our music, our languages, and our brainwaves is being kept safe by a metal shield that is slowly dissolving into the very space it is trying to navigate. The more humanity Voyager tries to carry, the more galaxy it has to endure. This brings us to a profound philosophical shift in the story. In the 20th century, we viewed Voyager as a tool, something we built to do a job. But 500,000 years into the future, the tool has become a celestial object. It is now governed by the same laws as the asteroids and comets. It has no propulsion, no guidance, and no voice. It is a ballistic relic, following a trajectory determined by slide rules and early computers in 1977 that has now outlived the very memory of the engineers who calculated it. We often talk about the memory of a machine in terms of its 68 kilobytes of silicon storage. But Voyager is developing a different kind of memory, a physical record of its travels. Each microscopic crater on its surface is a timestamp. The density of the pitting on its hull tells the story of the regions of space it has crossed. If an alien civilization were to find Voyager 1,000,000 years from now, they wouldn't just listen to the golden record to learn about us. They would study the erosion patterns on the metal to learn where the probe has been. They would see the scars of the local interstellar cloud, the impacts from the Oort Cloud, and the traces of radiation from distant supernovae. The machine has become a diary of the void, written in the language of damage. As we move toward the 1,000,000-year mark, we must confront the erosion of humanity on a deeper level. It isn't just the metal that is fading, it is the context. On Earth, the continents are shifting. The Africa we know is tearing apart. The Americas are drifting further away. The mountain ranges that were towering giants when Voyager launched are being ground down by wind and water. Species that existed alongside humans in 1977 are going extinct, and new forms of life are beginning to emerge in the ecological niches we left behind. In this timeline, Voyager is a constant in a universe of change. It remains structurally intact because, despite the sandblasting of the dust, the vacuum is still incredibly sparse. Metals don't decay in a vacuum. They don't rot or corrode without oxygen. Even the ancient circuits, though frozen and dead, remain physically present. The 1970s magnetic tape that holds the images of Jupiter and Saturn is still there, wound tightly in its reels, waiting for a playback head that will never come. But even a constant has a breaking point. As Voyager enters its second 1,000,000 years of travel, the interstellar weathering begins to reach the critical components. The delicate gold plating on the record is thinning. The structural bolts holding the dish to the frame are becoming brittle. The fossilization is almost complete. Voyager is no longer a visitor passing through someone else's neighborhood. It has been scoured and shaped by the Milky Way until it belongs to the galaxy more than it belongs to the Earth. The year is 1,000,000 AD. The most distant human-made object has traveled approximately 88 trillion miles from its origin. It has passed through clouds of gas and dust that we never bothered to name. It has been hit by 1,000,000,000 grains of sand, each one a tiny explosion that tried to erase its history. Yet against all odds, it is still there. It is a silent monument to a species that might not even exist anymore. If you were to find it now, you wouldn't see the sleek white explorer of the 1970s. You would see a dark, pitted, graying shape, a metallic ghost that looks like it was carved out of the void itself. It is the ultimate survivor, a testament to human curiosity that has been transformed into a cosmic relic. But as Voyager reaches this state of physical permanence, the very galaxy it calls home is about to change. The deep stellar drift is coming to an end, and the era of gravitational chaos is about to begin. Voyager has survived the dust, but now it must survive the stars. It is about to encounter the rogue worlds, dark, wandering planets that belong to no sun, and the violent gravitational tides that will decide its ultimate fate. The story of the erosion of Voyager is the story of our own fading footprint. We sent a message in a bottle, and the ocean is slowly wearing down the glass. But even a weathered bottle can still hold a message. And as Voyager 1 moves into the next million years, it carries the only thing of ours that might truly be eternal. The proof that for one brief, beautiful moment, we were here, we were brave, and we were loud enough to be heard across the stars. We have reached a point in our journey where the math begins to break. In the early chapters of Voyager's exodus, we relied on the precision of orbital mechanics, the same clockwork physics that allowed NASA engineers to predict a planetary flyby down to the second. We looked at the encounter with Gliese 445 and the transit of the Oort Cloud as if they were milestones on a well-mapped highway. But as we cross the threshold of the first few million years, we enter a realm that the original mission transcripts almost never discuss: the era of gravitational chaos. To understand this, we have to discard the image of space as a peaceful, empty cathedral. In reality, the Milky Way is more like a crowded, pitch-black room filled with invisible furniture. Up until now, Voyager has been traveling in what we perceived as a relatively straight line, a ballistic bullet fired from the barrel of the 1970s. But over the timescales of millions and billions of years, that straight line is an illusion. Voyager is not just moving through space, it is being tugged, nudged, and redirected by forces it has no way of detecting. The most unsettling of these forces comes from the dark wanderers, the rogue planets. We used to think that every planet in the galaxy belonged to a star, orbiting in a neat, predictable circle. We now know the truth is far more chaotic. Our galaxy is likely filled with trillions of rogue planets, worlds that were violently ejected from their home systems during their chaotic births. These are dark, frozen giants, ranging from the size of Mars to several times the mass of Jupiter, drifting through the interstellar void in total shadows. Because these worlds emit no light, they are invisible to our telescopes, and they would be invisible to the dead sensors of Voyager. Imagine the probe, millions of years in the future, drifting through a seemingly empty patch of the galactic disk. It has no radar, no cameras, and no way to know that a rogue gas giant 3 times the mass of Saturn is lurking just a few million miles away in the dark. As Voyager enters the gravitational well of such an object, a silent redirection begins. This is the gravitational chaos drift theory. Unlike the carefully calculated gravity assists at Jupiter and Saturn, which were designed to speed the probe up and point it toward its next target, a rogue planet encounter is a blind slingshot. It is a cosmic coin toss. Depending on the angle of approach, the gravity of this dark world could do anything. It could whip Voyager into a tighter orbit around the galactic center, or it could slow it down, dragging it toward the hazardous, star-dense regions of the inner spiral arms. In some of the most obscure corners of the lore vault and the deepest threads of the scientific community, there is a haunting, highly improbable theory: the return of the relic. This is the idea that over millions of years of chaotic encounters, a series of gravitational nudges could, by some impossible stroke of luck, slingshot Voyager 1 back toward the inner solar system. It is a poetic thought, the message in a bottle eventually washing back up on the shore that sent it. But the physics of the galaxy suggest a much darker reality. Even if Voyager were miraculously redirected toward the sun, the home it would find would be unrecognizable. Stars within the galaxy move far more randomly than we imagine. The Sun is orbiting the galactic center at about 230 kilometers per second, but so is every other star in our neighborhood, and they are all moving at slightly different speeds and in slightly different directions. This is relative motion chaos. If Voyager were to lap the Sun after 10 or 20 billion years, the solar system wouldn't be where we left it. The galaxy is a shifting sea of stars, and after one full orbit, the deck has been completely reshuffled. But rogue planets are only one part of the chaos. We also have to contend with the invisible ghost of the universe, dark matter. We know that roughly 85% of the matter in the universe is dark matter. It doesn't interact with light, but it has immense gravitational weight. Some theorists suggest that the Milky Way is filled with dark matter clumps, invisible concentrations of mass that act like gravitational potholes in the galactic road. As Voyager drifts through these regions, its path would curve and bend in response to mass that doesn't officially exist in any visual catalog. This creates the cosmic insignificance paradox on a structural level. We built Voyager to be a precision instrument, but in the face of gravitational chaos, it is nothing more than a leaf in a hurricane. It is a 1,600-pound piece of metal trying to navigate a landscape where the mountains are invisible and the ground is constantly shifting. By the time we reach 10 million years into the future, the very concept of a trajectory begins to lose its meaning. Voyager is now a galactic wanderer. Its path relative to the Sun has begun to curve significantly, not because the probe is turning, but because the Sun and all the surrounding stars are independently orbiting the galaxy at different velocities. Over millions of years, these complex relative motions create a spiral dance. Voyager might appear to be moving away from us, then closer, then off to the side, as we all orbit the great central black hole of the Milky Way at different rhythms. There is a terrifying possibility inherent in this chaos. Some calculations suggest that Voyager 1 is traveling at an angle of about 35 degrees. Relative to the galactic plane, this is like a car trying to drive up the wall of a bowl. While its current speed of 17 kilometers per second is nowhere near the 600 kilometers per second required to escape the Milky Way's gravity entirely, the chaos drift could change that. If Voyager were to experience a perfect storm of gravity assists, passing close to a massive star or a cluster of rogue worlds, it could potentially gain enough exit velocity to be flung out of the galaxy altogether. Imagine Voyager 1 leaving the Milky Way. It would leave behind the stars, the dust, and the chaos, and enter the great intergalactic void, the empty space between galaxies. Here, the distance between objects is measured in millions of light years. It would be a state of final isolation, where Voyager would truly be the only thing for an eternity of distance. It would be a cosmic orphan, outliving not just its creators and its planet, but its entire home galaxy. But for now, the probability remains that Voyager will stay trapped in the gravitational well of the Milky Way. It is a prisoner of the galaxy, destined to be tossed around by the invisible tides of gravity for billions of years. This era of chaos is where Voyager stops being a predictable machine and becomes a stochastic object, a thing whose future can only be described by probabilities, not certainties. As we look at the probe 100 million years from now, we see a craft that has been through the gravitational grinder. It has been pulled, pushed, and redirected. Its original mission, to head toward the constellation Ophiuchus, is now a distant, forgotten instruction. It is now following the gospel of gravity. What is most haunting about this chapter of the story is the silence of it all. At Jupiter, we could see the gravity assist happening. We could see the planet growing larger in the cameras. But in the era of gravitational chaos, there are no cameras. There is no one to watch as the probe is nudged by a rogue planet or bent by a clump of dark matter. It is a silent, invisible redirection that happens in the absolute darkness. The year is 100 million AD. On a planet that was once Earth, the very continents have rearranged themselves into new, unrecognizable shapes. The species that built Voyager is a ghost of the fossil record. But deep in the galactic disk, a small battered machine is currently being tugged by the gravity of a star that hasn't even been born yet. It is a tombstone carved in velocity, and it is currently being rewritten by the hand of the galaxy. Voyager has survived the interstellar weathering, and it is now surviving the gravitational tides. It is a testament to the fact that even in a universe of chaos, a message can still endure. But as we look toward the 5 billion year mark, a new threat emerges, one that makes rogue planets look like pebbles. The Milky Way itself is about to die. A collision with the Andromeda Galaxy is looming, a cosmic merger that will rearrange the very stars themselves. Where will Voyager be when two galaxies become one? To find out, we have to look past the chaos of gravity and toward the great galactic collision. We have to see if our message in a bottle can survive the destruction of the ocean itself. To continue our journey, we must now abandon the familiar ticking of the human clock and even the slow rhythmic orbits of the stars we recognize today. We are entering the era of deep billion-year time. We are moving into a future where the very map of the universe is about to be torn up and rewritten. By the time we reach the 4 billion year mark, Voyager 1 has traveled roughly 35 quadrillion miles from its origin. It has spent more time in the darkness than the Earth has spent orbiting the sun. But as the probe drifts, a shadow is beginning to fall over its entire home, a shadow cast by a giant. For as long as humans have looked at the night sky, we have seen a faint, fuzzy smudge in the constellation Andromeda. We knew it as a distant galaxy, a twin to our own Milky Way, sitting 2.5 million light years away. But what the early astronomers couldn't feel was that the Milky Way and Andromeda are falling toward each other at 250,000 miles per hour. They are locked in a gravitational embrace that can only end one way. By the year 4 billion, the deep stellar drift that Voyager has known for eons is interrupted by the greatest event in the history of our corner of the universe, the galactic merger. Imagine the view from Voyager's perspective, if its long-dead cameras could still see. For billions of years, the stars of the Milky Way have been a familiar backdrop. But now, a second galaxy is filling the sky. Andromeda is no longer a smudge. It is a gargantuan glowing spiral of 1 trillion stars, looming so large that it swallows the horizon. The two galaxies are beginning to collide. Most people hear the word collision and imagine a catastrophic explosion, like two cars hitting each other on a highway. But galaxies are mostly empty space. To understand the scale of what Voyager is about to experience, you have to remember the grain of sand metaphor from the sources. If the Milky Way and Andromeda were two clouds of dust, the individual stars would be miles apart. Voyager 1 is a single grain of sand passing through these two clouds as they merge. The statistical probability of Voyager actually hitting a star during this collision is effectively 0. Despite the billions of stars involved, the distances are so vast that Voyager will glide through the chaos unscathed. However, while the probe won't hit anything, it will feel the gravitational chaos on a scale it has never known. This is not the nudge of a rogue planet. This is a spectacular merger that gravitationally rearranges billions of stars. As the two galaxies pass through each other, their mutual gravity acts like a giant whisk, stirring the stellar populations. Voyager's trajectory, which was calculated with such precision back in 1977, is now at the mercy of this cosmic dance. There is a 50% probability that as the galaxies merge, Voyager will be swept up into a new, complex orbit within the resulting supergalaxy, a structure astronomers call Milky Way. But there is also a smaller, more haunting possibility. In the violent tug-of-war between these two giants, some stars and objects will be flung outward by centrifugal force. Voyager 1 could be ejected from the galaxy entirely. It could be thrown into the intergalactic void, the true nothingness between the islands of stars. If this happens, Voyager will leave its home forever. It will become a traveler of the great empty, a message in a bottle that has left the ocean and is now drifting in the open sea of the universe. But let's assume the more likely path, that Voyager remains within Milky Way. As the merger completes over hundreds of millions of years, the familiar spiral arms of the Milky Way dissolve into a giant, glowing elliptical sphere. Voyager is no longer an explorer of the Milky Way. It has become a citizen of a galaxy that didn't even exist when it was built. It is the ultimate survivor of a galactic apocalypse. And it is here, at the 5 billion year mark, that we encounter the most heartbreaking synchronicity in Voyager's story. While the probe is riding out the merger of two galaxies, back in the old neighborhood, its creator is dying. Our sun is finally exhausting its hydrogen fuel. It is beginning its transition into a red giant. The sources tell us that around this time, the sun will swell to a terrifying size, its outer layers expanding until they engulf Mercury and Venus. The pale blue dot, the world that Voyager looked back at with such affection in 1990, is now a scorched, airless rock, eventually to be incinerated or pulled into the sun's fiery atmosphere. Every mountain where a human stood, every ocean where life began, and every laboratory where Voyager was built is being reduced to atomic ash. Voyager 1 will be roughly 44 quadrillion miles away when this happens. It will receive no signal, no heat, and no warning. It will be completely oblivious to the death of its creator star. It is now the orphaned relic in the truest sense of the word. With the Earth gone and the sun collapsing into a white dwarf, a cold, dense core of carbon and oxygen, Voyager is no longer a representative of a living world. It is the only physical evidence that humanity ever existed. Think about the golden record in this context. It carries the greetings of 55 languages that are no longer spoken. It carries the haunting songs of humpback whales from an ocean that has boiled away. It carries the recorded brainwaves of a woman falling in love from a species that has been extinct for billions of years. In the new galaxy of Milky Way, Voyager is a cosmic Rosetta Stone, whose origin point has been erased from the map. By now, the interstellar weathering we discussed has had 5 billion years to do its work. The aluminum cover of the golden record, that sacrificial shield, is likely paper thin or scoured away entirely. The gold-plated copper disc itself is now the front line. But because the vacuum of Milky Way is still sparse, the record remains technically playable, even if it is battered and pitted by 5 billion years of dust. The message is still there, etched in the metal, waiting for a finder who no longer has a home planet to trace the message back to. We are now deep in the degenerate era of the probe's life. It has outlasted its stars, its creators, and its home galaxy. It is a tombstone carved in velocity, drifting through a universe that is becoming increasingly unrecognizable. Most of the main sequence stars like our Sun are dying out, replaced by white dwarfs and neutron stars. The universe is growing darker, colder, and lonelier. But Voyager 1 doesn't stop. It has no air resistance to slow it down, no friction to stop its progress. It continues at its steady 17 kilometers per second, a silent ghost of the 20th century. It has survived the great events of galactic collision and the death of the Sun by simply being far outside the danger zones. Its isolation, which was once its greatest tragedy, has become its greatest protection. The year is 5 billion AD. In the center of a new massive galaxy, a small dark artifact is still moving. It is a piece of 1970s technology that has become a cosmic monument. It is the last remnant of a dream that began on a small blue planet in a solar system that no longer exists. Voyager 1 has survived the end of the world. It has survived the end of its galaxy. And now it is heading into the final stretch, the journey toward the 10 billion year mark, where it will witness the slow, cold death of the universe itself. The message in a bottle is still drifting. The ocean has changed, the shores have vanished, but the bottle remains intact. We are no longer talking about a spacecraft. We are talking about the eternal Voyager, the only thing of ours that will ever truly reach the end of time. What happens when there is nothing left for Voyager to pass? To find the answer, we have to go to the very edge of the 10 billion year horizon. 5 billion years is a number that the human brain was never designed to process. If you were to count every single second of that time, you would be counting for over 158 million years. It is a duration so vast that it dwarfs the entire history of life on Earth, from the first single-celled organism to the moment you are watching this video by a factor of nearly 500. We are now entering the era of the Great Transition, a period where Voyager 1 ceases to be a representative of a living world and becomes something far more haunting, an orphaned relic. For the last 5 billion years, Voyager 1 has been drifting in the deep stellar drift of the newly formed Milky Way galaxy, surviving the chaotic merger of two galactic giants by simply being too small and too isolated to be noticed. It has been scoured by the dust of a quadrillion miles and nudged by the gravity of invisible ghosts, but its destination has remained essentially the same: away. But while Voyager has been busy surviving the galaxy, the cradle that built it has finally run out of time. Back in the old neighborhood, in a corner of the universe that Voyager hasn't seen in eons, the Sun is undergoing a terminal transformation. For nearly 10 billion years, our star has been a stable yellow furnace, fusing hydrogen into helium with the steady reliability that allowed life to flourish on the pale blue dot. But physics is an unforgiving master, and the Sun's supply of hydrogen is finite. Around the 5 billion year mark, the core of the Sun finally exhausts its fuel. The delicate balance between the inward pull of gravity and the outward pressure of nuclear fusion, a balance that has held for billions of years, finally breaks. The Sun's core begins to collapse, heating up to temperatures that are almost unimaginable. This intense heat causes the outer layers of the star to swell outward, expanding with a violent, unstoppable grace. This is the birth of the red giant. As the Sun grows, its surface cools to a deep, menacing red, but its proximity to the inner planets means absolute destruction. Mercury is the first to go, its rocky surface vaporized as it is swallowed by the solar atmosphere. Venus follows soon after, its thick acidic clouds swept away before the planet itself is consumed. Then, the sun reaches for Earth. By this point, roughly 7.5 billion years into the future, the world that Voyager once called home is already a ghost. The increasing heat from the swelling sun has long since boiled the oceans into steam and stripped away the atmosphere. The mountains that humans once climbed and the cities they once built have melted into a world of molten slag. Eventually, the Earth itself is engulfed by the sun's outer layers, incinerated until not a single atom of our civilization's history remains in its original form. The pale blue dot is gone, erased from the canvas of the universe as if it were never there. While this cosmic execution is taking place, Voyager 1 is drifting approximately 44 quadrillion miles away from the carnage. At this staggering distance, the probe is completely oblivious to the death of its creator star. It receives no radio signal, no flash of light that would alert it to the tragedy, and it feels no gravitational shift. The sun, which once dominated Voyager's sky and provided the gravity that defined its youth, is now just another bright, flickering light in the rearview mirror. Voyager 1 has survived the end of the world simply by leaving it behind decades before the fire arrived. This is the moment of the orphaned relic paradox. Voyager 1 is now the only physical evidence that humanity ever existed. If an alien intelligence were to scan the ruins of our solar system, they would find nothing but a white dwarf, the cold, dense core of the sun, composed of carbon and oxygen, surrounded by a faint, ghostly planetary nebula. They would see no cities, no satellites, and no bones, but 44 quadrillion miles away, a 1,600-pound monument of aluminum and gold is still moving through the dark at 17 kilometers per second. Think about the golden record in this new light. When it was launched in 1977, it was a message in a bottle, a hopeful greeting to a universe that might contain neighbors. But now, it is a tombstone. The recordings of the crashing of ocean waves are now records of a world whose oceans have boiled away. The singing of birds and the mother's first words to her newborn child are now the echoes of species that have been extinct for billions of years. The recorded brain waves of a young woman falling in love are the last surviving traces of human consciousness in a galaxy that has forgotten what a human even was. The cosmic insignificance paradox is now fully realized. Humanity's greatest achievement, the machine that outlived its own sun, is also a testament to how small we were. We were a species that lived for a microsecond of galactic time on a planet that existed for a fraction of the universe's age. Yet, we were brave enough to carve our voices into gold and hurl them into the infinite void. Voyager 1 is the only thing that prevents our entire history from being a silent, unrecorded event. As the sun sheds its outer layers and settles into its long, cold life as a white dwarf, the solar system becomes a graveyard of frozen cinders. But Voyager is already moving toward its next chapter. It has transitioned from a NASA spacecraft to a fossil from a long-extinct epoch. It is a time capsule that no longer has a destination because the concept of a home has been physically removed from the universe. The erosion we discussed in previous chapters continues, but now it is the only thing that happens. There are no more stars to fly by for a very long time. There are no more signals to send. There is only the steady, rhythmic impact of interstellar dust grains, each one a tiny explosion that slowly, atom by atom, scours the surface of the golden record's protective cover. The sounds of Earth are being carried through the dark by a machine that is slowly turning into the very space it travels through. By the time we reach the 8 billion year mark, The sun is a dim ember, and the Earth is a memory that doesn't even exist in the form of dust. Voyager 1, however, remains intact. Because space is so empty and the vacuum is so perfect, the internal circuits of the probe, though frozen at nearly absolute zero, are still there. The magnetic tape that holds the images of the pale blue dot is still wound in its reels. The technology is ancient, the power is gone, and the creators are dead, but the object persists. We are now forced to confront the finder narrative from a place of total isolation. If Voyager is ever found now, it will not be a meeting of two cultures. It will be a discovery of an artifact from a universe that no longer exists in its current form. The aliens who find it would not be able to visit Earth to see who made it. They would only have the probe itself, a piece of 1970s high-tech that survived the death of a star system. They would decode the records and hear the voices of ghosts, speaking from a pale blue dot that has been incinerated for billions of years. This is the true legacy of Voyager 1. It is not what it discovered at Jupiter or Saturn, and it is not the data it sent back from the heliopause. Its true legacy is its endurance. It is the eternal Voyager, the only thing of ours that will ever truly witness the deep time of the cosmos. It has outlasted its mission, its battery, its radio, its creators, and its planet. The year is 9 billion AD, in a galaxy once called the Milky Way, now part of a massive elliptical structure called Milky Way. A small dark artifact is still moving at 17 kilometers per second. It is etched with the scars of 9 billion years of travel. It is a tombstone for humanity carved in velocity, and it is currently heading toward the 10 billion year horizon. Behind it, the sun is a white dwarf, a tiny glowing diamond in the dark that no longer provides warmth to anything. Ahead of it is an increasingly dark universe where stars are beginning to burn out and no new ones are being born. But Voyager 1 doesn't care. It was built to keep moving, and so it does. It is the message in a bottle that survived the destruction of the ocean. Where will it be at the 10 billion year mark? To find out, we must look at the final fate of the universe itself. We are heading toward the end of the stelliferous era, where the lights of the galaxy begin to fade forever, leaving Voyager as a silent golden ghost in a universe of shadows. The cradle is gone, the creators are ash, but the Voyager remains a lonely, beautiful proof that for one brief, courageous moment, we were here. 10 billion years have passed and the universe has become a place of shadows and ghosts. We are now deep into what physicists call the degenerate era. The brilliant, chaotic nurseries of star birth that defined the night sky when Voyager 1 was launched are long gone. Most of the main sequence stars, including our own sun, have exhausted their fuel and collapsed into white dwarfs, neutron stars, or black holes. The Milky Way galaxy, born from the spectacular merger of the Milky Way and Andromeda, is no longer a bright, swirling spiral, but a dim, glowing elliptical sphere of aging stellar remnants. It is in this cold, quiet cosmos that the true climax of our story takes place. Somewhere in the outer reaches of this ancient galaxy, a scouting vessel belonging to a civilization we cannot even imagine detects a metallic anomaly. To these beings, who might live on a world orbiting a long-lived red dwarf, or perhaps within the artificial warmth of a Dyson sphere, space is not a void to be explored, but a graveyard to be cataloged. Their sensors, millions of times more sensitive than anything ever conceived at the Jet Propulsion Laboratory, pick up a tiny, dark artifact drifting at roughly 17 kilometers per second. It doesn't move like a comet. and its chemical signature doesn't match the surrounding interstellar dust. It is a foreign object, a piece of matter that has been scoured and shaped by a history that predates their own civilization by eons. As they bring Voyager 1 into their docking bay, they aren't looking at a machine, they are looking at a fossil from a long extinct epoch. To an alien archaeologist, Voyager 1 is a cosmic Rosetta Stone. They see a high-tech emissary from 1977 that has been transformed by 10 billion years of interstellar weathering into a pitted, graying monument. The 12-foot wide dish antenna, once the pride of NASA, is now a dull, scarred shield. The long booms that once held scientific instruments are bent and eroded, their delicate wires long since shattered by the silent rain of galactic dust. But as they begin their forensic analysis, the true mystery reveals itself. They find the 3 radioisotope thermoelectric generators, the nuclear hearts that once powered the probe. Even though the plutonium has decayed through countless half-lives, they can still detect the microscopic isotopic signatures of the fuel that once provided 400 watts of power to a tiny computer brain. They find that brain, a computer with 68 kilobytes of memory, and they are stunned by its simplicity. To them, this is like finding a primitive stone tool floating in the middle of a digital ocean. They realize that the beings who built this were a species that had barely begun to understand the laws of the universe, and yet they were brave enough to reach into the dark. The centerpiece of their discovery, however, is the golden record. Protected behind its sacrificial aluminum cover, the gold-plated copper disc has survived 10 billion years of travel. Even if the cover is now paper-thin or scoured away, the etchings on the record remain. The alien finders see the diagrams on the cover, the mathematical definitions of time, and the pulsar map that points the way home. Using their advanced technology, they decode the instructions and do the one thing the record was always meant for. They play it. For the first time in 10 billion years, the sounds of Earth fill a room that isn't on Earth. They hear the crashing of ocean waves from a planet whose oceans boiled away 5 billion years ago. They hear the singing of birds and the haunting songs of humpback whales from species that have been extinct for a duration that mocks the very idea of a lifetime. They hear greetings in 55 languages, the voices of a species that no longer exists, offering a hello to a universe that has long since forgotten them. Then they reach the most intimate part of the message, the recorded brainwaves of a young woman falling in love. To an alien mind, this might be the most confusing and beautiful data point of all. They are witnessing the electrochemical signature of a biological emotion from a species of bipedal primates on a pale blue dot that was incinerated eons ago. It is a desperate, beautiful poem of existence that was thrown into the cosmic sea in 1977, and it has finally reached a shore. The alien finders now turn their attention to the where. They use the pulsar map and the probe's own trajectory, that tombstone carved in velocity, to calculate its origin. They follow the path backward through the gravitational chaos of the Milky Way galaxy, undoing the 10 billion-year-old nudges of rogue planets and the spectacular merger of 2 galaxies. They point their telescopes toward a specific coordinate in the galactic disk, searching for the creator star. What they find is a white dwarf, a cold, dense ember of a star that was once a yellow sun. There is no Earth. There is no pale blue dot. There is only a field of scorched debris and a tiny glowing core of carbon and oxygen. They realize that the message they are holding is a message from a ghost. Voyager 1 is an orphaned relic, the last remaining proof that a civilization once looked up at the stars and decided to leave something behind. This realization brings them to the cosmic insignificance paradox. They see that we were a species that existed for a mere microsecond of galactic time, yet we were capable of creating an eternal Voyager that could outlast the stars themselves. To the finders, Voyager 1 is not a piece of space junk. It is a monument to the audacity of the human spirit. We didn't send a weapon, and we didn't send a warning. We sent a symphony, a greeting, and a heartbeat. The alien finders are left with a haunting question. Who were these people? They have the data, they have the music, and they have the brainwaves, but they will never know the feeling of a sunbeam on a human face or the sound of a human laugh in person. They are looking at the last human object, a time capsule without a destination that finally found one. In this moment, Voyager 1 has fulfilled its true mission. It has bridged the gap between a dead world and a living one, ensuring that our story did not end in the fire of a dying sun, but in the hands of someone who cared enough to listen. The aliens don't throw Voyager back into the dark. They realize its value as a silent monument to curiosity. Perhaps they place it in a museum on their own world, or perhaps they send it back out with a message of their own attached to its frame. But as they look at the golden record, they understand the final truth of the 1977 mission. Voyager 1 did not need to be found to matter. It fulfilled its purpose the moment it left the Earth, carrying the pale blue dot into the infinite blackness as a testament to the fact that for one brief, beautiful moment we were here. The year is 10 billion AD. The universe is cold, the stars are dying, and the creators of Voyager are long gone. But in a room far from where it began, a machine made of aluminum and gold is still telling the story of a small planet that once dreamed of the stars. The message in a bottle has been opened, and the voice of humanity is finally heard across the deep, dark ocean of time. We have finally reached the edge of the map, a destination that lies 10 billion years into a future so distant it mocks the very concept of time. To understand where Voyager 1 is at this moment, we have to discard the human calendar and even the geological scales of Earth. We are now standing at the 10 billion year horizon. If all of human history, from the first spark of fire to the launch of this probe, were compressed into a single heartbeat, we would still be staring at a duration of time equivalent to an entire biological lifetime of the universe. The universe has entered what physicists call the degenerate era. The brilliant, chaotic nurseries of star birth that defined the night sky in 1977 are a memory of a distant golden age. The stelliferous era, the age of bright burning suns, is winding down. The Milky Way and Andromeda have long since completed their violent, spectacular merger, settling into a massive, glowing elliptical orb known as Milkomeda. But the glow is fading. Most of the main sequence stars, including every sibling of our own sun, have exhausted their fuel. The galaxy is now a silent graveyard of white dwarfs, neutron stars, and black holes, the cold, dense cinders of a brighter age. In this landscape of shadows, Voyager 1 is still moving. It has become a fossil from a long extinct epoch, a piece of matter that is now significantly older than the majority of the stars it passes. At 10 billion years of age, Voyager is no longer a spacecraft in any functional sense. It is a sculpted relic. For 10,000 millennia, the steady rain of interstellar dust has acted as a slow-motion sandblaster, meticulously reshaping the machine. Every dust grain, even those only 1,000th of a millimeter across, has slammed into the probe at 17 kilometers per second, creating a tiny, vaporized crater. The white paint that once bore the logos of NASA and the United States has been scoured away, atom by atom. The structural lattice of the spacecraft, once hidden behind protective blankets, is now exposed, looking less like a piece of 1970s high-tech and more like a dark, metallic asteroid. It has been weathered and shaped by the Milky Way until it belongs to the galaxy more than it ever belonged to the Earth. It is a time capsule that has become the very thing it was sent to study, a permanent feature of the deep void. But deep within this battered, graying shell, the core mission remains. The golden record, shielded behind its sacrificial aluminum cover for eons, is the final surviving trace of our world. By this point in history, the pale blue dot has been a ghost for 5 billion years. The sun, which once provided the gravitational tether for the Voyager's youth, is now a dim, cold white dwarf, a tiny diamond of carbon and oxygen that no longer provides warmth to anything. The Earth itself was incinerated long ago. Its oceans boiled and its mountains melted into the solar atmosphere during the sun's red giant phase. Every mountain where a human stood, every ocean where life began, and every laboratory where this probe was built has been recycled into the galactic medium. Voyager 1 is the only physical evidence that any of it ever happened. It is the tombstone for humanity carved in velocity. We are now forced to confront the cosmic insignificance paradox in its ultimate, most haunting form. We were a species that existed for a mere microsecond of galactic time. We rose from the dust of ancient star deaths, looked at the infinite blackness, and for one brief, courageous moment, we were loud enough to be heard. We built a machine with less memory than a modern car key and sent it into the infinite blackness. And against all mathematical odds, that tiny, fragile effort has outlasted everything else. The music of Bach, the greetings in 55 dead languages, the haunting songs of humpback whales, and the recorded brainwaves of a young woman falling in love are still traveling through a universe that has forgotten the word human. The technology is ancient, the power is gone, and the creators are ash, but the message persists. The golden record, etched in copper and plated in gold, has survived the merger of two galaxies and the death of its home star. It is a cosmic Rosetta Stone that no longer has an origin point on the map. Over these 10 billion years, Voyager has likely completed several full orbits around the galactic center. While it moves at a steady 17 kilometers per second, the stars around it have moved in a chaotic, random dance. Even if Voyager were to miraculously pass back through the specific coordinates where the solar system once sat, it would find nothing but an empty graveyard. The solar system and nearby stars do not return to their original positions after one orbit. The deck is reshuffled by the relative motion of billions of objects. Voyager is truly a wanderer with no home to return to, even in theory. We must also consider the gravitational chaos drift that has defined its path over the last several billion years. While its trajectory was originally a straight line, it has been nudged and redirected by the invisible tides of the galaxy. It has felt the tug of rogue planets, those dark, frozen giants that drift through the void without a sun, and it has potentially been bent by clumps of dark matter. These silent, invisible encounters mean that Voyager's ultimate destination is no longer a matter of calculation, but of probability. It is a leaf in a galactic hurricane, following the gospel of gravity through a dark, unrecognizable forest. As we look toward the even deeper future, we reach the limits of our current scientific understanding. Trillions of years from now, the universe will grow even darker as space continues to expand, pushing other galaxies beyond the horizon until Milky Way is a lonely island in a sea of total blackness. Some theories suggest that even the atoms of Voyager themselves might eventually face an end. Over unfathomable timescales, the very subatomic particles that make up the aluminum, the gold, and the copper of the probe might begin to dissolve through quantum processes like proton decay. Or perhaps it will eventually be captured by the intense tidal forces of a neutron star or fall into the event horizon of a supermassive black hole, where its information will be preserved in a different, more permanent way. But for all practical purposes, at the 10 billion year mark, Voyager 1 is eternal. It is a message in a bottle that has outlived the ocean itself. It is a physical refutation of entropy, a proof that intelligence and curiosity once existed in a universe of cold, indifferent physics. The most unsettling truth may be that Voyager 1 did not need to be found to matter. It fulfilled its true purpose the moment it left the Earth, carrying the essence of our world into a future where we would no longer be there to tell our own story. The story of Voyager 1 is not a story of distance, but of duration. It is the longest story ever told. It is a testament to the fact that for one brief, beautiful moment in the history of the cosmos, we were brave enough to reach into the dark. We were a species that lived for a heartbeat, yet we created a monument that could witness the end of time. The year is 10 billion AD. Somewhere in the direction of a constellation that no longer has a name, a small machine made of gold and aluminum is still moving. It is carrying a message from a species that once looked up at the stars and decided to leave something behind. It is the last of us. It is the eternal Voyager. And as long as it is moving through the silence of the degenerate era, humanity will not be entirely gone. It is a silent golden ghost wandering through eternity, a beautiful, desperate poem of our existence that will never truly stop.